In spring 2025, day-ahead power prices were negative 18% of the time in Spain, a huge shift considering that before 2024, negative prices on the day-ahead market had never occurred in the country. This simple statistic, combined with grid constraints and cheaper batteries, is pushing developers to test new co-location strategies to protect the business case for solar. But co-located sites are notoriously tricky to model, as the investment case depends on a combination of site-specific and market factors. These include grid connection limits, solar yields, ancillary market rules, commercial structure, and solar battery interactions that can each have a significant impact on revenue. In this video, we'll take a standard front-of-meter solar use case in Spain and look at how Gridcog can be used to model different co-location options. We'll start by configuring the existing site, which includes a tracking ground-mounted solar farm that follows the sun's position. Gridcog also provides advanced parameters that let us adjust factors such as losses, degradation, maximum tilt angle, and ground coverage. Note that if users had their own solar data, they could also upload the data in our library. In this example, 70% of the solar generation is under a PPA, while the remaining 30% is sold on the wholesale market. To reflect that, we'll use submeters to model market exposure on part of the solar assets. We'll also add the existing grid connection limits, 0 MW for imports and 40 MW for exports. Now that our baseline site is set up, we can compare it to a co-located case by cloning our baseline and adding a battery. But how do we know how big the battery should be? Rather than rely on guesses, Gridcog can search for the optimal combination of co-located sites for solar, wind, and battery assets to maximize project cash flows. In this case, we're just going to auto-size our battery, so let's take that option. Next, we'll review the commercial model. The developer still has the solar PPA income, but on top of that, we have wholesale and ancillary revenues from the battery. We've configured an optimizer that will take 10% of the profit for market access. Before we run the simulation, we'll add a third scenario in which we'll increase the grid import limits from 0 to 20 megawatts to increase the arbitrage opportunity for our battery. Now that it's set up, let's run the simulation and check the results. Starting with some energy data, we notice that the auto-size feature gives us a 100 megawatt-hour, 2-hour battery as the optimal size. With this, over a third of the solar energy flows through the battery. When imports are enabled, that share drops slightly, but the battery now imports significantly from the grid to make use of negative and cheap wholesale power prices. Finally, looking at cash flows. PPA revenue, in pink, stays stable across all scenarios, while wholesale and ancillary revenues in orange and purple respectively rise sharply as soon as a battery is added. This increase largely offsets the battery capex over our project lifetime of 12 years. We've just seen how Gridcog delivers results tailored to your site, grid limits, and commercial arrangements, but this is only a fraction of what the platform can do. Get in touch if you'd like to learn more.